Okay, so uh, today's problem gonna be this one. I attempted to solve it, like I read it during the contest, but I didn't have enough time to solve it, so I'll try to do this now, to read it and try to solve it. So basically the idea, I should start removing the edges here. So that vertex 0 should be reachable from all, and it's directed graph. Directed, okay, directed weighted graph. I have to remove some edges from the graph, possibly none, so that satisfies the following conditions. Node 0 must be reachable from all other nodes. The maximum edge weight in the resulting graph is minimized. If I remove this edge, so the only question is if I gonna if I gonna remove the max edge, will the node 0 be still reachable? So in this case, if I remove this edge 2 to 0, from 2 to 0, then the vertex 0 is still reachable from 2, because so every time I remove the edge, I should do the following. I should somehow figure out if the vertex is still connected to other vertices. If it is connected, then then I'm fine. Let me think. If I okay. So if I substitute this graph, this edge, so like gonna be so the problem with this, so let's check this one. So the threshold is 1. So I should remove all edges except one, so that minimize minimize the weights, minimize the maximum weight. So the number of edges here is what? N, number of vertices is n. There can be solve loops and weight from the 1 to 10 to the power of 6. So here, if I do this graph, 2, 3, 1, and then this one, and then 2, 4, 0, 5, 3, 1, 2. So here the threshold is actually 1, meaning I should get rid of all the edges. Like here I have like 3 outgoing edges. 3 edges. Here I have like 1 edge outgoing. Here I have 1 edge outgoing, etc, etc. So so obviously I should remove edge, this one and this edge, and then I should return 2 as a max edge. So should I reverse like reverse the edge like have a G reversed, and then expand if it's like if the vertex is reachable to the 0. So I'll go DFS or like BFS, and every time let's say BFS, and every time if it's like vertex is reachable, I'll mark it like reachable here and go this way and this way, reachable, and then I go this way, also reachable, and then all of them are reachable, and then if I do like this and this, so if all of them are reachable, I can I should first satisfy the threshold, and then I should look up for the top. So that I should get the vertices one by one. Not vertices, like I should analyze the, let's say I have the, say, Q or whatever with edges. Let's say this one Q had like 3 edges. Like one has like 3 outgoing edges, and everybody else has like 2 have 1 outgoing edges, 3 have 1 outgoing edges, 4 have 1 outgoing edges, and 0 has like 0 outgoing edges. The maximum edge weight, each node has at most threshold outgoing edges. So first of all, I wanna like remove the edges so that the the vertex is still connected. So I'll start removing, like I remove 5, and I check if the one is still connected to 0. In order to that to be still connected, it should have other edges that are connected to edges to the vertices that are connected. So I remove this one, and then I remove this one, and then it's still connected. And then I have one edge, one edge, and the maximum is 1 here now. And then I go to 2. I check basically all the vertices from the queue, and check if I can if I can remove the threshold. Oh, if I can remove the edge from there, and that if it will still be connected. I wonder if just how can I remove the edge if I remove it like blindly. I don't know, it's a little bit hard problem. If I'm gonna be removing it blindly, I wonder like if I don't go like all the way. So like if I remove like, let's say this edge.
Hi Dad.
Hello,
I brought a couple of guests.
You brought a couple guests?
Yeah.
Who are they?
Try to guess.
Have no idea.
It's Kaga.
Your school teacher?
And please drum roll. Trisha.
Okay.
I just need them to shoot off.
Okay, so like 0, 1, 2, 3.
Same or mine. It's freezing. Oh. There, bye. Oh my god. Okay, let's go. To my room. Okay.
So from 0 to 2, from 0 to 3, from 0 to 4, from 1 to 2, from 1 to 4. So obviously those are not reachable. Let me read the hint. That's very interesting approach. So like I say okay, all edges. That's pretty fun. So I should invert the edges, as I said. And let's say that edge from, let's say, 0 to 2, like all the maximum so if I invert all the edges, and let's say I can say that I can go only on edges that have weight less. Let's say I do a binary search for the edge weight, and I do I can only go on a graph. I can follow the edge only if the weight is lower or equal to selected, and then it's gonna be like, let's say initial weight gonna be huge, and then all, if it's like connected graph, all of them gonna be like can be followed, and all vertices will be reachable. And in this case, like if G reversed, all vertices are reachable, then means that graph original have like zero index, zero vertex reachable from all the vertices, all other vertices. So if for the reverse graph, the all vertices are reachable from 0, then for the original graph, 0 is reachable from all the vertices. And then I'll do this W like weight selection, and then for the all weights that are lower or equal the selected weight, I will follow the G reverse to the all vertices, and check if all vertices are reachable. If yes, then I'm gonna like I'm gonna decrease the W. Let's say we have upper bound like W with wave, and then lower bound 0, and then I'm gonna try to do double weight like W with wave over 2, and then check if the I can follow the to all vertices from 0. This is gonna be G reversed. If all vertices are reachable for the W with wave over 2, then means I need to go further, decrease the W over 2, like decrease the target. And if it's like no, not reachable, I need to step back and look for solution in the right part. So that's gonna be it. Let me check what the timing is now. Okay, so I'll try to program it as fast as possible now. So let's say I'm gonna have G for int I equals I less than edges length I plus plus, and then I'm gonna have this reverse graph as so I have all the, so I can't have just array list of G equals new array list, and then the number of number of vertices, and then for the all the edges I'm gonna go G if G edges 2. So I also want to be for it to be weighted. So inside it, it's gonna be array list of int is equal now, then G edges 2 equal new array list, and integer G edges 2 add, then new int and edges 1, and then no edges 0 1 1 here 1, edges 0, and then the weight edges 1 no 2. Okay, so that can be the graph, And then I'm gonna have like say boolean, the private boolean BFS. Then I'm gonna have the graph passed. Graph. And then I'm gonna have this int target, or like thresh, say weight, target weight, and then I'm gonna go q int integer, and then also gonna have an and then no, I need just n vertices, say, okay, and then here boolean visited equals new boolean n, then q equals new linked list. Let's say let new q dot offer 0 visited 0 equals true, and then while q is empty, while not empty, I'm gonna go q dot poll, then int v can be this one, and then int array list of this name. So I'm gonna go through the neighbors equals g v, if neighbors equals null, continue for int neighbors. I'm gonna check if the if not visited, then int visited count equals 0 or like 1. If not visited this neighbor 0, then I'm gonna go if and let's say and the weight to visit it and the neighbor 1 less or equal target weight. I'm gonna go visited count plus plus, and then q dot offer neighbor 0, and then visited neighbor 0 goes through, and then in the end I need to return visited count should be equal n if it's like reachable, if all vertices are reachable from vertex 0. So I saved the reversed graph here, and then I need to go binary search. So let's say good good equals good equals 10 to the power of 6. Bad equals 0. So I need to go while bad minus good, or like good minus bad, greater than 1. Then I'm gonna have int target equals bad plus good minus bad.
No.
In the trick or treat.
No, we need that for trick or treating.
Over
You
2.
don't want that to smell like orange. No.
Then I'm gonna check if BFS target G, and if it's true, I need to go at in middle. And then good equal
Wait, do you want to just?
else
I
bad
think we can.
equals
I think we can do it in this one. We just need to wash it.
Come on.
Go.
I hope that those Orbeez don't become like those and Frogies. Even inside.
if
Imagine even inside.
then if good is equal 0, so I need to to capture this, like if it's not reachable at all. So if it's not gonna be reachable at all, the good gonna go up to 1. So it's like gonna be not reachable, not reachable, not reachable, and then reachable as soon as I increase. 6 0, okay, 6 zeros. Let's call so in case let's call it so I'm more used to, let's call good. I'm more used to what? -1, 100, this one, and then if good is equal 0, so I should return, actually I should return good. If good if bad is gonna be equal if bad gonna be equal this if bad is equal this number, I should return -1. Return -1. Otherwise return good. Some kind of that logic. Array list, okay. New array list. So I wanna save the. Okay, if I'm gonna explicitly use it. Array list like that. If G edges 0. Okay, edges I. I then edges I. BFS. Target weight graph and then N. The problem, target conventional M. Okay. Visited. Okay, so what's the most efficient way to solve this problem? Oh, okay, so some people are using the sort edges and they are doing what? Adjacency add. So they add adjacency list and they do so with the weight is the same. They wanna do the increasing order of vertices, but if edges is not the same, they wanna basically the if it's gonna be like E1 is greater than gonna be. So they wanna like have the weights, the vertices with a higher edge weight to be on the first, in the beginning of this adjacency list. And here, if visited source is equal to visit destination is equal to 0, with destination count plus path. If visited visit yeah, I'm gonna probably wrap up. We'll take this as a home assignment, understanding this approach. I assume it's something like just filtering that what I was trying to do in the first half of this video before beginning the hints. Yeah, that's it. So I claim it as a fail, because I didn't come up with a nice approach, like with a solution within like first 20 minutes, so it's fail.